All right, ladies and gentlemen, time for our next set of Module 2 notes. Go ahead and put my name and number in the corner up here, since that's how we always start. That and with broken pencil lead. Okay, as I said, we're in Module 2, continuing with our second lesson today. I'm hoping this one will go fairly quickly as it is reviewing things that we've gone over previously. We're going to be touching on some rounding and estimating again, just sort of getting a little bit bigger. In fact, that is part of the title. For Module 2, Lesson 2, you are going to be estimating larger products. Okay, so larger products, thinking about larger multiplication problems here in Lesson 2. We've got our Roman numeral 2 right there. Someone mentioned the other day, why are we starting over? Well, again, we're in Module 2, so this is the second lesson in Module 2. Okay, some vocabulary today. Again, probably some familiar vocabulary. We're going to start by once again thinking about the difference between rounding and estimating. Because you will hear me say both, I'm going to try very hard not to switch them around, even though sometimes I do. Rounding means changing one or more, and today it's going to be more. Changing one or more numbers. Okay. Changing one or more numbers to make operations easier. Ideally, you want to try to make operations completely mental. You want to make it something you can do in your head. Estimating is one of the few times I go against my teacher impulse to tell you, everything on paper, everything on paper. You're going to do a little on the paper, but for estimating and rounding, you want to try to do it in your head. Now, the estimating itself comes after the rounding. After you have changed one or more numbers. After. Let's underline it. I wish I could circle it. I wish I could highlight it. I wish I could draw little pictures. After you round. After rounding, perform the operation. Remember, the whole point of rounding was to make the operation easier. So you want to wait and do it after you've rounded. Okay, again, nothing particularly new there. This next section is not going to be particularly new either. But I do want to make sure I run through it with you. Okay. Now, we're going to start. There are a few different ways to estimate, but we're just going to focus, I think, on one right now. Okay. So this procedure, this process, is just going to be regular rounding. I've spoken briefly about compatible numbers. We'll deal with that once we get into division again. That's when that's really useful. But for right now, regular rounding, the rounding you've been taught before. So, for example, okay, and I know this procedure is not going to be step by step like they so often are, but we've done this once or twice already. I want to show you a different way of looking at it. So, for this example, round 213 to the nearest 10. No decimals or craziness right now. Don't worry, we'll get back to that stuff later. For right now, 213 to the nearest 10. Let's go through our little rhyme. Find your place. Okay, well, if my place is the nearest 10, then in 213, that's going to be this digit right here. I have 1 in the tens place. So find your place. Go next door. Okay. So, 213, you guys are going to love me for this. I swing around next door, I look at this, and I say, okay, what have you got going on for me, next door neighbor? Remember, the digit in the place you're rounding to, that's what's going to change. And it's trying to decide, first of all, should it change? Should it just rest? Or should it soar? Should it fly upwards and grow 1 greater in power? Okay. Find your place, go next door. So I'm looking next door at 3. Now the rhyme continues, 5 or more. Let it soar. So if this is 5 or more, it's going to tell the number in the tens place. It's going to tell the number we're rounding to soar. Well, the number in the tens place looks next door, and that is not 5 or more. That is less. That is less than that. So I think to myself, nope, it is not 5 or more. Okay. So I continue, 4 or less, let it rest. So I do the whole bit again. I'm in the tens place, I'm looking next door, and I'm asking, is that 4 or less? To which this time I respond, yup. 3 is going to be less than 4. If it had been 4, I still would answer with a yup. Okay. Now, 5 or more, let it soar. 4 or less, let it rest. This part doesn't rhyme, but I kind of like it. Roll out the 0, or zeros. Okay. Sometimes you have more than one. And yeah, it kind of falls apart at that point. It's not really a rhyme, but we'll make do. So everything on the left stays the same. The number we were working on, well, it either soars or rests. In this case, it is going to rest. And then everything on the right-hand side turns into a 0. I had a student tell me one time, I thought this was very clever. The student said that they used to look at this number, the next door neighbor, and figure, well, after it gave advice to the place we're rounding to, this number's exhausted. And it just passes out. So there's nothing left. Kind of silly, but it helps me remember now. Something I might suggest to some of you. All right, so when do we get to the part where we're estimating larger products? All of this is fairly familiar. Okay, you asked for it. 28 times 8 times 89. Still not horribly huge, but we're getting there. What I am always going to suggest, and the book sometimes I think overcomplicates it. For once, it's not me overcomplicating it. I'm going to try to simplify it. Anytime you have something, round to the greatest place value. Round to the greatest place value. Now, for 28, that means the tens place is the greatest place value. I look next door. Okay. 5 or more? Yup. So the 2 is going to soar. It's going to become a 3. Now, we roll out the zeros, but I'm going to make it just kind of a phantom 0, and I'll show you why in a moment. I'm going to jump to 89, because I think this one will be pretty easy. round to the greatest place. The greatest place is the 10. That's the farthest over to the left. The one that's farthest on the left, the 10's place. I look next door. 5 or more. We have another one that gets to soar. Now, this is tricky because I told you previously with a single digit number just to leave it alone. But now that I'm getting a little bit bigger, I'm looking at this and thinking, ugh, I rounded this one to the 10's place. I rounded this one to the 10's place. I kind of want to round this one to the 10's place. If it had been 4, 3, 2, or 1, if it had been 4 or less, I would just leave it alone. But because it's so close to being 10 anyway, 8 and 9 are so close to 10, in this case I will round it up. Now, on a test, I will make sure that I don't give you anything that's that close, that's hard to read. But I did want to talk about it. Okay. Now that I've rounded everything to the nearest 10 and broken my pencil lead again, I can wrap this up. Think about how we multiplied mentally. We boxed any non-zero digits and multiplied across. Again, this is another reason why I wanted to turn the 8 into a 10. 3 times 8 is 24. That's no problem. 24 times 9 is maybe a little trickier. This, however, is super easy. 3 times 1 is 3. 3, the answer. 3 times 9 is 27. Okay. So I'm going to go back for just a moment. 28 times 8 times 89. I am saying is approximately equal to 30 times 10 times 90. Remember how I took those invisible zeros? I wasn't really thinking about them. I'll make sure I write it so we can see that. Then I count the invisible zeros. 1, 2, 3. 1, 2, 3. I want to make sure they're there properly. They shouldn't really be invisible. I just wanted to focus on those digits. Okay. So my answer, 27,000, 27,000, okay, tells me that 28 times 8 times 89 is approximately equal to 27,000. And the real number is going to be a bit lower. I rounded everything up. 28 went up to 30, 8 went up to 10, 89 went up to 90. So that's going to be a bit of an overestimate. If I'm rounding things up, then yeah, this is going to be a little high. But hopefully not too terribly high. When I use the calculator, I know it's really hard to see on the screen. 19,936. That is off by a bit. That is off by a bit. But I still have a 5-digit number. It's not too terrible. If I had done this with a single digit, if I had done 30 times 8 and then multiplied that times 90, I would have gotten a significantly smaller answer, 21,600. That would have been much, much closer to the real true answer. So this would have been a more accurate estimate. Again, that's why I usually tell you to leave the single digit numbers alone. But sometimes we make compromises for things we can do mentally. As always, we'll talk more in class. I know I repeat myself a lot, but I do understand that estimating is tricky for a lot of students. It is not as concrete. It's not as step-by-step solid as a lot of things in math. There are a lot of different ways you can approach it, and that makes it tricky. Do your best. I am going to ask you to show your work, but what I'm going to ask you to do is just show me what you're rounding to. Again, you don't need to write this out and multiply because the whole point is you shouldn't have to. But if you can show me what you rounded to, 28 to 30, 8 to 10, 89 to 90, then if your answer is different than mine on a test, I can at least see why you got yours. And if your arithmetic, if your calculations are correct, and your estimation makes sense, I can give you partial or full credit. So take your time, write what you're estimating to, and pay attention in class in the next few lessons as we continue to practice this. But that's it for notes for now. So I will bid you adieu and see you in class. Thanks, folks.